So let me give you a theorem. Maybe you might want to press pause and have a quick read of this theorem. So press pause and have a quick read. So when given an alternating series, to decide whether this alternating series will converge or if it will diverge, if all three have been satisfied, then you can say that this alternating series will converge. And here the reason why we're using UN here is because, well, normally when we're given normally this whole thing here is your AN. Well, here, because we want to isolate this thing here, we want so for example, let's look at our alternating harmonic series. Normally this whole thing here would be considered as AN, but because we just want to talk about this component only, we want to isolate this. We want to isolate this bit here. We don't want to talk about this. We just want to talk about this component here. So normally AN is considered as a whole thing here. But then because we just want to talk about this component, we need a new name for it. We can't call it AN because AN is a combination of the two. So we assign a new name to it. Let's call it UN. So UN here is really us isolating it away from this thing here, because all this is doing is it's giving us the minus, it's giving us the plus, it's giving us the minus. That's all that this thing here is doing. We don't want to talk about this bit, so we assign a new name. So remember, AN is a combination of the two. So because we want to talk about this component only, we assign a new name to it. Let's call it UN. So when given an alternating series, if all the UNs make sure all the UNs are positive. So if you look at our example, the alternating harmonic series, our UN here is 1. Remember, we don't care about the sign. We don't care about the sign. Our UN here is a half. Our UN here is a third. Our UN here is a quarter. And all these are all positive. They're all above 0. So this is good. It has been satisfied, the first part. And then the next part is eventually non-decreasing. The next term must be lower or equal to the current term. So the next term, so in our sequence here, let's say something like this. Let's say something like this. So this is our UN plus 1. Our UN here is saying the next term must be smaller or equal to our current term. So the next term must be smaller or equal to the current one. So what it's saying here is that eventually, this eventually part is saying, suppose you have a function looking something like this. So something weird is happening around here. Something weird is happening around here. But there exists a capital N. There exists a capital N where all n equal to or above the capital N, it will eventually be non-increasing. So non-increasing means this. Hang on. So non-increasing means this. It could go down, and then it could stay the same, and then it could go down, and then it could stay the same. It could go down. So this here is good. It goes down and then stays the same, goes down, stays the same, it goes down, stays the same. So this non-increasing here is good. So that's okay. But if you have something like this, hang on. You see, by the way, and we require that UN, the limit of UN, heads towards 0. So the limit, as n tends to infinity, it heads towards 0. So condition 3 is that we require the limit to be 0. So if you look at this here, 1, and then a half, and then a third, a quarter, we are heading towards 0. We are heading towards 0. So back to this number 2 here. This is an example. So this here is no good. Even though it's heading towards 0, the limit is heading towards 0. But this is bad because it will require us to be all positive, non-negative. So here, this part is negative, negative, negative. So this is bad. This is good, but then this is bad. Yeah. So this here is another example of it. Hang on. So suppose you have something like this. Hang on. So this is good. It's heading towards 0. All positive is good, but this is bad because here, well, it has to be non-increasing. So non-increasing could mean it could stay the same. So this is non-increasing. Goes down and then it stays the same. Goes down, stays the same. This here is non-increasing. Non-increasing means it doesn't increase. So, but then if you look at this example here, this is increasing here. Is then increasing here. Is then increasing here. So for this example, this is good. This is good, but then this is bad. So this is no good. But then if you look at our alternating harmonic series, all three are good. You see, this is good because it is heading towards 0. So just the UN itself is all the UNs are heading towards 0. So for our example, the alternating harmonic the alternating whatever, this is heading towards 0, and they're all positive and they're all non-increasing. So therefore, because all these three have been satisfied, we can say that this alternating whatever is heading, well, it will converge. Okay.